Okay. So for this structure, we know, right, this is the same as this in terms of deformation at this end. Okay. This is positive shear. Yeah, I'll write this out again. In fact, it's TY, it's not TX. I got it wrong. Yes, TY. It's positive shear. Okay. So it's by identifying the deformation. Okay. Just to let you know whether is it positive shear or negative shear. Okay. So this is, yep, we are, so once you have done this, okay, we go into Mohs Circle, right? We will go into Mohs Circle, right? So now we have what? We have so for example, we want to analyze element H, for example. Okay, so we want to analyze element H, right? So if we look at element H, okay, so again, when you look at element H, you have to draw your orientation. Okay, so this is my X, right? So the vertical is my X, the horizontal is my Z. Okay, right? Okay, so this is your element H, right? So we found that the shear is at that direction, positive shear. So we draw positive shear, right? Right, and then the X direction, we only have stresses in the X direction. Okay, so this is your stresses. Okay, so for element H, this is the value that we'll be using, right? And then the shear is this value that we'll be using. Then we go into Mohs Circle. Okay, then we go into Mohs Circle and we determine principal stress. And then I'm going to tell you why principal stress. Okay, right. Let's look at another now. The next example. So I know civil engineers. This class have civil engineers, and this is a very good problem for mechanical engineers because it's a round shaft. Okay, I know civil engineers, you do round stuff. Okay, you do some round structure, but not a lot. Okay.
Just a quick question.
Yes.
So in this case, we're not considering the other component of shear stress, which is VQ over IT, because the shear force V is 0.
Yes.
Okay.
Lucky. Woo! Right. So, but the next problem, we will not be so lucky. Okay. Again, I say again, the next problem, we will not be so lucky. Okay. Right. Okay. So let's look at the next problem. Now I cannot find my mouse. Okay. So the next problem is a structure like this. Okay. So again, the problem. I see how much space I get now. Right. So this is the next problem. Okay. So this is our example number 2. Okay, we are going to take all we know. Okay, we're going to apply now. Right. So we have seen a structure like this already. Okay. So the first thing to do is you have to identify the transformation. Right. So the rules exactly all the same apply. Okay, the rules exactly all the same. Nothing is different. The good thing about this, okay, the good thing about this, I'm going to see. The good thing about this is there's no torque. Okay, the good thing about this. Okay, there's no torque. Okay, so what we have is 4 force are applied to a W200, 41.7 row mill. Determine the principal stresses. Okay, maximum shearing stress at point A. Point A is where our element A is. So if you were to print this out, okay, so I'll show you where point A is, right? So point A is over here, okay, where my cursor is now. There's where point A is. Or you can see from here, right? I think you can see where point A is. And then the beam has W241.7. So for this case, I know this is not the real world, okay? This is just a problem that's given. So what we are trying to do is, okay, now we know what forces are applied. We have to use this cross section, okay? Why have to? It can be 110 reason. Have to is probably because it's the cheapest in the market now, right? It can be, or nothing's available because of the virus. Okay, it can be anything. You get what I mean? So as an engineer, your principal engineer will come and tell you, Peter, can you tell me my stresses at point A? I need to make sure that this won't fail. By the way, we have ordered this cross section already. Okay, just let me know. Okay, so what information we can gather? Okay, so what information? So I given you the scenario when this is possible. Ideally, you don't want this situation to happen. Okay, but you know what? Poop does happen. Okay, so we are given. Okay, so we have.
What if you are in that situation and you realize that it's gonna fail? What do you do then?
Then, when that's the case, you tell them what's the limit of the load. Do not exceed this much.
Oh, okay.
Right? You tell them, hey, you have loaded yourself in a situation. We have already bought this already. Do not use this amount of load because it's not going to work.
Okay.
So as engineers, we can make recommendation, but we don't make the decision. Unfortunately, the decision are made by, made by not engineers. Okay, the decision are made by people that has money power.
Which is kind of dumb.
That's the reality. Okay. So these are the tables that are given. Okay, you see me pasting the tables now. Okay, you see me pasting the table now. Okay, so what is given is we have bought this material. Okay, so we got this material. Right. So these are the associated geometry. Right. So if you look at the figure down here, this is your X and Y, which is the same as your diagram X and Y. Okay, you know what? I have something to request from you guys. I'm going to stop the lecture here, but I need to talk to you about something that we don't enjoy doing. Okay, then we'll come back to you. Hold on.